Okay, students, question number 5. Compare the following pair of surds. So, the two surds are given. We have to compare. So, if you compare according to their radicands, so we have to compare, but here the radicands are different. Also, multiplier are the different. So another method is that, so first, convert it. 7 root 2 is equal to, here the students, 7 we have to convert it into root 9, means root 9 square root of 49 is 7. So we have to convert it, 7 convert into the root 49. So square root of 49 is 7. So 7 sevens are 49 into root 2. Okay. So here the students, these are both in the roots. So multiply the numbers 49 into 2. So 49 2s are 98. Okay. And next third is the 5 root 3. 5 root 3. So similarly 5 you have to convert into the root of 25. So the is a perfect square of 5. Okay. So in the root of 25, 5 is the perfect square, 25 is the perfect square of 5. Okay. So into root 3. So these are roots are same. So root 25 means like that their multiplication we have to do 25 into 3. So the multiplication is a root 75. Okay. So if you compare both the surds are both in the root same, the roots are same, means the order is same, square root 2 and the number radicands are different. Okay. So we have to compare the radicands 98 and 75. So obviously 98 is greater than 75. So obviously square root of 98 is greater than square root of 75 because we have to compare the radicands. So obviously the 98 root of 98 is greater than root of 75. Means obviously the 7 root 2 is greater than 5 root 3 because root 98 is the simplification of 7 root 2 and root 75 simplification of 5 root 3. Okay. So 7 root 2 is greater than 5 root 3. Another example, root 247 and root 274. Here the students, both the orders of both the surds are same, is a 2. Okay, here the order of the surd is the same, means the order is a 2 because it's a square root, and the radicands are different. Okay, so we have to compare the radicands, means the numbers. 247 obviously is less than 274. So the students have to say that root 247 is less than root of 274. Okay. Fourth example, 5 root 5 and 7 root 2. Okay, students, here the order is same but the radicands are different and also the multiplier is different. So we have to just simplify it. So 5 root 2, 5 root 5. So we have to simplify it. So the 5 we have to convert into root, means root of 25. So root of 25 answer is a 5. Okay, into root 5. And their multiplication means 25 5s are 125 because both the roots are same. These are both the square roots. So the multiplication 25 5s are 125 into square root. So root of 125. Another 7 root 2. Here the same, square root of 49. So we have to convert 7 into root, means root of 49. So root of 49 answer is a 7 into root 2. So 49 2s are root of 98. Okay. So here the both the order is same but the radicands are different. So we have to compare the radicands. So obviously 125 is greater than 98. Obviously the root 125 is greater than 98. Means obviously 5 root 5 is greater than 7 root 2. Sixth example, 5 root 3 and 9. Okay students, so obviously these are the irrational numbers, but this is your normal number, means is an integer, maybe okay. So देखिए 5 root 3 same process apply here. So 5 you have to convert into root 25. So root 25 is obviously 5 into root 3. So just multiply the numbers because the root are the same. So 25 3s are 75 in the square root of 75. So 9 number students, obviously we have to convert into irrational number. So we have to take the square root of that. So square root of 81. So square root of 81 obviously is a answer is a 9 because 9 9s are 81 square root. Okay. So okay students, we have to compare their radicands because both the roots are same. So obviously 75 is less than 81. So 5 root 3. So 5 root 3 is less than 9. So obviously 5 root 3 is less than 9. Next example, 7 and 2 root 5. Same example like that. Okay. So 7 we have to convert into root of 49 and the 2 root of 5. Obviously same process apply. We have to take the square root of square root for that. So root of 4, in root of 4 the answer is 2 because square root is a perfect square into root 5. So 4 5s are, means obviously root is same, so root of 20. Okay students, so if both the orders are same, square root, and the radicands are different, so we have to compare the radicands, means numbers. So 49 is greater than 28. So obviously root of 49 is greater than root 20. So obviously 7 is greater than greater than 2 root 5. Okay students, question number 6. Simplify. Here the students, some of the certs are given. We have to perform the operations like addition, subtraction. So the two certs are given. We have to do addition here. So means 5 root 3 plus 8 root 3. These are the two certs. We have to do the addition. So very simple students. If both the certs have the radicands are same, also the order is same. These are the multipliers, 5 into root 3 and 8 into root 3. Okay, so both the certs have the radicands are same, 3 3, and the order square root both are the same. So very simple, we just common the radicands. So means we common the root 3, so we just separate the 5 plus 8 into bracket root 3. So the 5 plus 8 is equal to 13 into root 3. Very simple like that. In second example, 9 root 5 minus 4 root 5 plus root 125. Here the students, these are the three certs. We have to do this operation subtraction and addition. But in both the certs, when the radicands are same, these are in the square root and the radicands are same, but in the third certs is a root 125. So we have to 125 is convert. So how to convert? See that 9 into root 5 minus 4 root 5 plus. We have to just find the factors of 125. So 25 into 5. Okay. Again we have to get a simplification. 9 into root 5 minus 4 root 5 plus. We have to separate the multiplication. Root 25 into root 5. Okay. So the students, again simplification, 9 root 5 minus 4 root 5, same terms plus. So root 25 obviously is the perfect square of 5. Perfect square, so the answer is 5 root 5. Okay students, so in the three terms, both the surds in the three terms, when the radicands are same, 5 5 5 in the root 5 root 5 root 5, so we have to just common the root 5 in the both three terms. So 9 minus 4 plus 5 into bracket, so common is a root 5. So we okay, so we cannot do the operation on that. So obviously, so 9 minus 4 is a 6, 9 minus 4 is a 6 and plus 5. 9 minus 4 is a 5, so 5 plus 5 is equal to 10 root 5. Okay, so you just do the operation and the common surd is obviously root 5, so you just multiply that. Okay, next example, 7 into root of 48 minus root 27 minus root 3. In the three terms, we have to do the operations, subtraction, but the three terms have the different radicands. Order is same, but the radicands are different. So we have to just convert the same radicands because order is same. Okay. So 7 into root of, so 48, we just find the factors of 48. So 16 3s are 48 minus 27. Obviously root of 9 3s are 27 minus root 3. Okay, we're gonna again we have to simplify it, separate the terms. So 7 into root 16 into root 3, separate it, minus root 9 into root 3 minus root 3. Okay, so is equal to, so here the 7 into, so obviously root 16 is a perfect square of 4, so the 4 and 4 4 are 16, so the 4 into root 3 minus obviously we have to convert 3, so now 9 is a perfect square of 3, so the 3 into root of 3 minus root 3. Okay, so again simplify it, 7 4s are 28. So these are the common terms, 3 into root 3 minus the root 3. Okay, so we just common the root 3 in the three terms. Okay, here the students multiplier is 1. Is not given, but you have to just consider it. Okay, so we just separate that, we just common root 3 in the three terms. So 28 minus 3 and minus 1 into bracket into root 3. Okay, we just simplify it. So there is simplification is a minus 3 is a minus 4 and 28 minus 4 is a 24 because sign of the bigger number. So 24 into root 3. Okay. Okay students, so another example is root 7. Root 7 minus 3 upon 5, root 7 plus 2 root 7. Here the students, in the three terms, when the terms are same, root 7 root 7 root 7 means radicands are the same. Okay, but in the second terms irrational number is given. Okay, so there is no problem. So how to do that? Okay students, so we have to just common the root 7 in the three terms and we have to do the operation of the terms. So 1, here the multiplier is 1, so minus 3 upon 5 plus 2. Okay, so students, here we already do the operation of the rational numbers, so we will do that. You can just common the means you just common their denominators. Okay, so here, okay students, so we just equal the denominators. Okay, we just multiply that. So if you multiply here 5, denominator is 5, so 5, obviously you have to multiply the numerator also to 5. So 5, so minus 3, also here we will to multiply the denominator 5, so the also the numerator will be multiplied with the 5, so 2 5s are 10, means so 5 minus 3 plus 10 upon 5, because we have to equal the denominators. So we already learned operation in a previous standard. So 5 minus 3 plus 10 upon 5. Okay, so the students here, 5 minus 3 is 2, and so 2 plus 10 is equal to 12 upon 5 into multiplier root 7. So we can do the simplification in this process again. So the our answer is 12 upon 5 into root 7.